Hey, you guys, welcome back to GraphQL Radio, the GraphQL podcast. Today we have Erik Schlegel. Schlegel, did I say it right?
Yeah.
Oh,
Yep, you
man.
got Schlegel almost there.
I almost got it from Microsoft. And I'm Avi Iyer. I'm your host. And today I have my co-host.
Hey, I'm Johannes Schickling, and I'm actually the person who can pronounce Erik's last name in the right way, since it's German, so it's called Schlegel.
Oh.
All right.
Welcome to the show, Erik. I'm so glad you joined us today.
Well, thank you for inviting me. Appreciate it.
All right, awesome. So Erik and I actually got in touch a couple of months ago when I've reached out to you since you were about to give a talk at the React Austin meetup about GraphQL, and I think this was kind of like the first time you gave a public talk about GraphQL. If I'm not mistaken, it was about GraphQL Subscriptions. That's how we kind of got in touch. And I've learned about all of the exciting projects you're doing with GraphQL, which goes way beyond what normal developers would use GraphQL for. And that got me so intrigued that I just wanted to have you on the show. But before we dive into all of that, I just would love to hear about your path to GraphQL. So you're working at Microsoft, you're probably more exposed to OData normally. So did you guys dive into GraphQL because of Microsoft? Did that happen?
So I'm a senior engineer on a team called the Partner Catalyst team, and the group was started about 2.5 years ago. And our main charter and goal is to help accelerate Microsoft partners. And these partners can be local startups, accelerators, or large NGOs like the United Nations, and help solve their really tough, most challenging problems and use emerging technologies to drive innovative solutions. So the team was started by Satya 2.5 years ago, and he felt that the only way to drive innovation is showing up to customer sites and truly understand their gaps and their issues. So one of the projects that we started and embarked on a little over a year ago was a project with the UN, specifically a group called OCHA, and they're responsible for planning humanitarian aid around the world. So they provide humanitarian aid plans for disasters that range from famine to refugee displacement to terrorist attacks. So very often the plans that they need to provide are in some of the most dangerous parts of the world. So Benghazi, Aleppo, Mosul. So they don't actually have access on the ground. They don't. Some of their deployment folks, they cannot actually enter the area. So they need to, in order to provide accurate aid response plans, they need to understand what the discussions that are happening on the local ground. So what they've done in the past is they do that by phone conversations, monitoring Twitter feeds, Facebook pages, local news and blog sites, and also radio is a big part because it's probably one of the most unbiased media sources out there, just with the fact it's so unfiltered. So you can imagine a team of 5 to 10 people monitoring all this information every day. The amount of, the manual nature and the imprecise accuracy around that, and the turnaround time for coming up with these aid plans, you can imagine that it's quite delayed. So depending on the extent of certain disasters that are happening, timing is critical. I mean, timing could save lives. So we worked on this project called FORTIS, and what it is for most of the part, it's a data collection pipeline that's collecting data from a variety of different social media and public news outlets, and collecting the information based on a watch list of topics that a partner is interested in monitoring, as well as a part of the world. So they have an interface, they draw a box in the world and saying, I want to monitor this particular part of the world. We evaluate all this data coming in real time, and we geolocate the conversation, the fragment of that conversation, and then we filter out any portions of the conversation that fall outside of that geofence. Then we are using sentiment analysis as well as topical feature extraction off of those fragments, and also doing things like named entity recognition.
Nice.
And we also have the ability to tap into radio. So we tap into radio feeds in real time. We take audio streams, convert it to text, do that same level of operation that I mentioned earlier about the feature extraction off of actual audio. So we then take all this information, we aggregate it up, and we provide trends and insights and visualizations. And that last portion, that's the true key. That is what the aid response workers need a better understanding, a better hold on, better grasp of, to be having that more insightful look through into how certain topics, how certain main entities have been trending over time. One other example is we're working with the World Health Organization to help combat Zika virus. So with Zika virus, the only way that you know that a specific part of the world is impacted with Zika is if people talk about it in social media. They talk about the symptoms they're experiencing. So if you are able to predict where Zika virus is spreading by looking at weather forecast data and where mosquitoes are moving based on temperature changes and precipitation level changes, and you focus on the area, and then people start talking about those symptoms, then you can figure out where Zika is going if people start talking about rashes and fevers. So where GraphQL comes into all this is all the partners that we deploy FORTIS to needs more flexibility and control on how they grab insights into this data. So having things like graphical and the tooling within Apollo with being able to have that playground IDE to play around with the data set. The tools around with GraphQL to be able to stand up a GraphQL backend very easily. This is why we went with GraphQL, because it provides a flexible developer experience for both developers and designers to get more insight into the data set.
That's awesome. So you're definitely building such a product that is really not like shown in like the GraphQL community right now, right? You know, the biggest GraphQL example is Facebook, obviously, and you know, think of what Facebook is to us versus something like Project FORTIS, which is like super in depth and super like niche to developers because they're not really part of that kind of, they don't have exposure, right? Now, you guys got an opportunity to build this with new technology in a famously old company. How did that go down? How were you so flexible to do that? And if you were to use your previous set of tools, would you have been able to be this successful?
One of the things that when we work with partners, we have a lot of flexibility and freedom to use what's the best tool for the job. Majority of the frameworks and the tooling that we use is open source, just because it evolved very fast, and the amount of the contributions that are provided from a variety of different companies and accelerators and individuals. So our team is one of the leading ones within Microsoft that really are leading the charge in open source adoption and contributors, not just using open source, but also contributing back to open source. So, it would be very hard for us to be as successful as our team is today without open source. And with the emergence of GraphQL and all the tooling that's being contributed to GraphQL, it just made the most amount of sense. Just because we get so much tooling within that stack for free from the community that it's been such a pleasant experience.
Right. So you kind of described quite in depth how you use how the problem looks like, and you motivated like where it's being used, and that it especially provides a lot of value to these peoples who need to get more insights. So I'd be interested in two things. One is, who are these people who need to get more insights? Are these people who need to visualize data and they just have a better way to access this information? Or who are these people? And the second question, I think this is where we'll dive into afterwards, is how are you exactly making use of GraphQL, where we can dive a bit more, a bit deeper into the real tech stack. But yeah, maybe we want to first talk about like who are these people using GraphQL from a consumer perspective?
So yeah, so it's a good question. The people that are using the FORTIS tool are the aid relief workers. It's the actual operations team. It's the research team that is monitoring a specific part of the world, and we provide them a dashboard, an insights dashboard, where they have almost think of it like Facebook Live in a way, where you have a heat map that shows where all these topics, where all these events are taking place. So we're able to identify anomalies and trends and topics that we're monitoring. So what's powering the visualizations on this dashboard is GraphQL. So one example of the visualization would be showing where sentiment has changed across the region and where topics have been mentioned, like the distribution of topic mentions over a given location and how that's changed over time. So you could think of a heat map, and then above the heat map, almost like a time series, like a histogram. So you could select a time period, and then you could click play, and as that's playing over time, you'd actually see that visualized on the heat map, almost like think of it like a weather forecast map, but with events. That whole piece I just described is all powered through GraphQL.
Okay, so I'm trying to picture what does the GraphQL schema looks like for these kind of events, since there are like so many different dimensions. Like you mentioned that time, you mentioned location. There are probably different dimensions of social media channels. So how are you kind of structuring your schema? How has that changed? I think this is like one of the core fundamental advantages of using GraphQL, that you have like so much flexibility in designing that. So how does that look like?
So the way that we do it is the data is indexed. So we have a schema. So you can think of like a location tile. So all the information we're collecting, we aggregate it based on a geo tile. So you can think of it like a tile on like a Google map or a Bing map. So it's a square in the world. So we organize it by a tile ID. Now, the other data portion is all then indexed by a time period. So we'll index it by, the month of May, all the hours of the day, by hour, by minute, by day, by month, by week, and then by year. So then we index it by the topic that we're monitoring. And all the associated other topics that were mentioned alongside that one topic, as well as what is the average sentiment for all that information, and as well as source. So what's the source that the information is coming from? So we have it indexed at that schema through Spark. So as the data comes in, we're using Spark streaming to be able to aggregate this data in real time. So we have a Spark cluster running across a Kubernetes cluster. And so the data is being aggregated to the level I mentioned earlier, and then using leaflets to actually represent that information through GraphQL queries through Apollo server.
Okay, I see. So you kind of like having all of this data in a Spark cluster. So how does your but I think this is where do people actually run their GraphQL query against? So there needs to be a GraphQL server that needs to proxy the Spark cluster. So how does that infrastructure look like? Is this like written in Node and it's like fairly simple, or how does that look like?
Yeah, so the way that works is we have a Node microservice server where it's based on our GraphQL server. So all the queries run. So our dashboard is in a React-based dashboard web app. That's Node, and that talks to the GraphQL server. So the data is the persistence layer within FORTIS is all backed by Cassandra. So what happens is the data is aggregated in Spark through real time. Once the aggregate operation is completed, then we push the data to Cassandra. But with GraphQL subscriptions, we mark that a mutation has just taken place. So within our GraphQL, so we then push that into a pub sub system powered by Event Hub in Azure, and our GraphQL server then responds to that event, marks that as a mutation, and then those changes then are flushed down to all the React components on our React-based dashboard.
Nice.
Right.
That's a really cool setup, and that's kind of like, I like the use of Event Hub. That's kind of new in the subscription space right now in GraphQL. Like most people are using Redis or Q2T or whatever the hell it is.
We are using Rabbit internally.
RabbitMQ, yeah. And so that's a really different one to bring in the mix, which is kind of cool. I do have some questions about this overall architecture. I really like that you kind of laid it out for us. Now, I think I've read this architecture before. You guys are using Postgres, right, for at all? Yeah, for actual storage. Now, how many like requests do you get for like the initial queries? Like, what's like your number of requests per month to display the page, things like that?
I don't know. That's a good question. I don't know exactly what the number of requests, because if you think about it, it's mostly all the components are all based off a push model. So as mutations occur, then we're pushing data out of the components. So when the dashboard first runs, we then register all of our subscriptions, the data comes in. And as the data is changing, and I think that the time span that we're running our Spark Stream cluster, I think is every 10 seconds. So you can imagine that the data is being updated and pushed out every 10 seconds. Mutations are happening through Cassandra, then through Event Hub, and out to our GraphQL subscriptions every 10 seconds. So this has a very clean model so that we're not continually polling our GraphQL server. Yeah, we're only updating the stuff that changes on the dashboard.
Okay, that's super interesting, since I think this is what most people don't quite understand about GraphQL subscriptions from the beginning, is that they are there are a couple of extremes. Either you initialize your entire app with normal GraphQL queries, and you just use GraphQL subscriptions to kind of like get an unread message count or something like that. And then there's the other extreme, like you mostly described it, that you don't really do initial queries too much, but you kind of populate your entire applications based on the data you're getting off your subscriptions. And I think that this is really interesting, that it's like, even though I've just presented these two extremes, most applications are somewhere in the middle. And I'm really excited to know about an extreme case like you've presented it, where this makes a lot of sense. So just to go back to Avi's question, what is kind of like the throughput there? So since all of that is event driven, like how much data are we talking about there?
So the aggregation data that's in the data volume is mostly on the heat map, because if you can think about it, it's all based off. So whatever your map bounds is currently set within the heat map, it's the tiles within that. But if you think about it, the way that heat maps and geotiles work is the data is being aggregated based on the zoom level that you're at. So if you're at a very high zoom level, you're still not pushing that much data because you're at a very high zoom level. So the data volume per read is, I would say, probably in terms of the amount of mutations, we're probably talking maybe every 10-second push, we're probably talking maybe 1,000, maybe 500 to 1,000. So the data payload is pretty light, if you think about it, because of the way that we designed it with leveraging geotiles.
Nice.
Because what we're persisting in Cassandra is exactly the tiles that we need to render on the map. So the data is already presented at that point anyway. So when the mutation comes in onto the dashboard, we have all the data we need right then and there to actually visualize it and react.
I feel like that's going to be a really cool paradigm with like Apollo server-side rendering, and then right away you just pick up everything else from subscription. You kind of handle the base query. I kind of preach this concept for subscriptions called the base query. That's like the first query for the list, and then you have everything else is subscriptions after the base.
Yep.
And so you kind of have an option, like, am I going to do optimistic UI updates, or I'm just going to rely on my subscription, or am I going to do both, But I never really thought of it as, why even have a base query? Just render the page and then just have your subscriptions pick everything up,
Right. And even the work that we're doing with Event Hub, with the integration of Event Hub and subscriptions, we're planning on contributing that back in, because right now there's Rabbit as a pub sub subscription for GraphQL, and then there's Redis and there's RabbitMQ, and I believe that's it. So the Event Hub piece is one that we're also contributing.
Yeah. So on that note, like setting up GraphQL subscriptions for like really trivial concepts, like something's added to a list and stuff. That's like really straightforward, and it's really nice. When you have visualizations and like, a really complex UI that it has many different queries with many different responsibilities. Like, what are the problems of developing something like that? Like, what are those bugs where you pulled your hair out and you're just like, what the heck is going on?
It's mostly not on the GraphQL side, but it's on the Spark end of aggregating complex schema like that. You can imagine, with Twitter, we are receiving about, I want to say, 8,000 tweets a second. Facebook, about 9,000 posts a second. Bing, we're pulling down, there's 5 billion web pages that we're searching against, and radio real time. So you can imagine the data volume is pretty massive. Yeah. And scaling on a cluster to be able to aggregate data and be able to get it right on the geotile side, that part's the most complex, actually. Once the data is flowing into Cassandra, then the GraphQL piece is quite relatively straightforward from the Spark side of things.
Right. So, so adding up on like running a subscription server on your own, I think that also places quite a few challenges. So compared to a normal HTTP-based GraphQL server, which is stateless, I think that, you can really easily implement that using Express and so on. And you can, it's easy to scale. But as soon as you have subscriptions, you have to think about state. Your servers are stateful. Scaling isn't as trivial anymore. So did you run into any sort of problems around that?
Yeah, we're right now. So this piece that we're building, so subscriptions is something that we implemented probably, I would say, a month ago, maybe 3 weeks ago. Before that, we were polling. So we're relying heavily on the Apollo side to actually manage state on our Redux app. So we haven't ran into those issues yet, but we're about to actually put this and test this into the wild over the next few weeks. So.
Yeah, WebSockets bring a lot of complications to infrastructure-wise too. Especially, it's good because Amazon has like an application-level load balancer, so that's nice, and that will make subscriptions a lot easier to, build and deploy on the DevOps side. But let's go back into the client, because you stated that from what it sounds for your project, the Apollo or the GraphQL or whatever libraries you're using on the front end, it was just like a piece of cake. Like, you got through it, and that wasn't the hardest part of the project. Are you using Apollo client or are you using Relay?
We're using Apollo. Yeah, okay. We're using Apollo. And we decided to use Apollo just because it just provided quite a bit of flexibility from a developer experience standpoint, with just interfacing with their queries and binding your store to our data store. I haven't had the opportunity to check out the recent version of Relay, though. I'm not sure. I've heard that the next version of Relay, the recently released version of Relay, is quite an improvement. So yeah, I'm pretty psyched to check that out.
So we also, just like the previous episode, we actually had both Lee Byron, Joe Savona, Sashko, and Jonas, both from Facebook and Apollo, on the show, and we talked about like Relay Modern, where Apollo is going, and how Relay definitely won back a lot of the flexibility, and how they define themselves, like what is Apollo, what does make Apollo great in like a couple of months ago, where does Relay compare against that? So I think it's definitely really interesting to check out both. We are currently working on a couple of tutorials to get started with Relay Modern, since this is still the same problem as with Relay in the very beginning. That there is a lot of technical documentation around it, but it's not as easy yet to get started. And I think this is one of the main selling points also of Apollo, that it's so much easier to get started, and at the same time it's very flexible. So why shouldn't you use it? So
it was built by the people, man.
Yeah.
It was built by the people.
Right.
But it's also interesting in the fact that both are emerging, because it will bring out the best in both frameworks, and there'll only be more tooling, more features added with both. The fact that you do have the presence of Apollo and Relay, both teams will be working nonstop to actually make those grades.
Right. So, but you mentioned it, like in your position at Microsoft, you're actually not just working on the project FORTIS, but you're actually also, you've worked on other projects in the past. Maybe you're working on another one right now, where you've already been using GraphQL. So was it kind of like the same the same goal, to use GraphQL to give more flexibility to people who visualize data, or was it a completely separate usage?
Yeah, so there's another project that our team is focusing on that wants to provide more flexibility for developers around the analytics we're collecting for bots. So we have a dashboard where a designer will be able to say that I want a donut chart to get these types of insights of bot analytics that we're collecting. So for a variety of different partners. So what this project is seeking to build out is almost like a designer, where you could actually come in and say, okay, I want to put a donut chart here, a bar chart there, a heat map here, and then having flexibility to configure this data source, the data query that's powering that visualization. So we're currently going through GraphQL and trying to see if that, as a prototype, to see, okay, can GraphQL do what we're the scenario that what we're basically seeking the goal of this app, of this scenario. So so working on just educating the variety of different developer groups about GraphQL and the tooling and how to use it. So that's currently going.
All right, and I think that kind of you're using a GraphQL feature there, I think, which is not often used as a main motivation to use GraphQL, but just the fact that you can not just dive deep into a certain resource and traverse the data graph for a specific resource, but with a single request, you can access so many top-level items at the same time. And when you're talking about like here a heat map and here another bar chart or something like that, I mean, in my head that translates back to how the GraphQL queries.
Right.
Like if you would do that with a non-GraphQL API, you would send like dozens of HTTP requests, which would be horrible.
You'd have to have chain REST requests and
Exactly.
parallel, be responsible for merging the responses of that. Yeah, I mean, GraphQL just takes care of that for you. You structure the data. The schema is structured in a way that how you want to present it on your interface. And you have the flexibility with defining your own resolvers. So having that parallel capability for making requests out to your backend server and having the ability to stitch that all together in a single response is just a beautiful thing. So, it's all about minimizing latency and minimizing the number of round trips you have to make to a database server, which I don't know any other framework out there that does that better than GraphQL.
Yeah. So pretty much, from what it seems, you're in. You're like full on. And
yeah. Oh, no.
And
you're preaching to the choir.
Yeah.
I definitely don't need to be convinced.
But so I think part of like a developer advocate, and I feel like everybody on the show right now is a developer advocate for GraphQL. How did you bring this, or how are you planning on bringing this to Microsoft as a bigger entity?
Yeah, so 2 weeks ago, I gave a GraphQL talk at Microsoft's Build conference, actually going technically deep with FORTIS and how we're using GraphQL. And the audience was predominantly Microsoft developers. So educating that audience about the benefits of GraphQL, the types of problems and challenges that it resolves, and just going through more of the rudimentary basics of GraphQL. And then as we add more features to FORTIS, also talking about how GraphQL was used, the driving factor. It's mainly through talks and conferences and meetups, and through blog posts and code stories. So,
how has the reception been for the people that come and watch these talks? Are they excited to get involved, or are they going through red tape now because they're interested? They try to get it in? Or?
I think that once people understand, I think at first it's a tough concept for a lot of developers to grasp when you see it for the first time. And I think that once developers use it and understand it, really understand it, they love it. They're completely hooked. I think that there's some education though that I find in some parts that just educating the crowd on what are the great benefits of GraphQL. A lot of the questions we commonly get is, why use GraphQL versus REST versus OData. So that's one of the common questions that I typically get.
Right. So how did you usually answer the question to? I think just yesterday I saw a Twitter conversation around I think a pretty experienced developer at Microsoft asking should I use GraphQL or OData? And there were a lot of people answering. So for a person working at Microsoft where you already know OData, and I think this is always a pretty big point that people usually stick with what they know, what they are efficient with. So why should people who are efficient with OData, why should they switch?
So there are many reasons. So the versatility that GraphQL has with a variety of other stacks. So we have a polyglot persistence layer. We're using Postgres, we're using Cassandra. To have one service that could talk to both, that has more flexibility with the concept of mutations, with subscriptions, and also the amount of tooling that's out there for GraphQL as opposed to a lot of other frameworks, and how there's already bullet-proven frameworks that have integration with GraphQL for things like React Native and React.js and Android, and so many different frameworks out there that you can just take something off the shelf and just plug it in and just use it. And the community itself too. So, and then also, being able to make one request and parallelize that across a variety of different calls and have that culminate and stitch together with a common response. You can't get that with OData or REST, bare bones. There's frameworks out there that do it, but it's not as, it doesn't have the adoption, and it's definitely not as proven, I guess, from a framework and a tooling standpoint that does all that.
Yeah, so the next thing to kind of wrap up the show, we want to talk about ideas for the future of GraphQL, things that can help developers maybe onboard easier, develop their products easier. Do you mind sharing any ideas?
Yeah, so one of the things that we're planning on using GraphQL, pairing GraphQL with, is Storyboard, so that designers can have a list of implemented front-end components and being able to bind GraphQL queries to those components. So Storyboard is a great way to actually have a listing of all your components and documentation behind that, and kind of play with those components and fully understand its functionality. The GraphQL add-on integration that's been put in place with Storybook is good. It's a good start, but to carry that forward, I think as having the ability to have GraphQL adopt and integrating with a designer-like interface with something like that, I think would be really incredible. Also, a lot more tooling around subscriptions as well. As subscriptions is going to emerge, and it's going to grow so at such an accelerated rate. So many people are starting to do so much with it today. So, and it just was released not too long ago. So I see a lot of tooling around just, buttoning up the subscription side of things with GraphQL.
Right. So something which is really interesting to me is like with the entire project FORTIS, you're using GraphQL for the sole purpose of providing a better foundation for data visualization. So what did you find were kind of like the low-hanging fruits where people could easily take these ideas and build open source tools around that, where you could kind of map directly certain GraphQL queries to certain React components, for example?
Yeah, so that's one of the things that we're looking at potentially contributing right now, is being able to actually have a storyboard configuration in place, and then being able to actually have, integrate the GraphQL, like a graphical like playground where you could actually play with the data and then integrate that with that component itself. So, working on actually trying to contribute that, and it's one of the scenarios that we need to support for FORTIS. So
awesome, man. So those are pretty good ideas, and I really like the storybook idea. With the current add-on, definitely it's not really as flexible. But the cool thing for listeners is you can mock out your GraphQL schema in Storybook using Apollo test util. So if you're using Apollo, it should work with any GraphQL schema, but you could do that in your Storybook already. But where I think Erik's getting at is, it's not, I had to do it myself. There's not like a one-line, do it and you're done. And if anybody listening wants to build something like that, hit me up. Let's do it. So there's a lot of good things we talked about. Mostly good because we all like this technology. But what's something that you'd like to change about GraphQL?
I don't know about change. It would be good to see more tooling around authentication. Just seeing that more naturally supported, more natural tools there. Because I know that there's some plugins around Passport. If you're using GraphQL and Node and Express, there's some Passport middleware. But some formal tooling around Auth.
So are you just talking about authentication, but also about authorization?
Authorization, because authentication, there's some tooling out there, but authorization would also be pretty.
Gotcha. Right. Yeah, I think there are a couple of very interesting ideas currently floating around. So I've seen that. I think Max Stoiber sparked an interesting conversation. I think in some of the Apollo repositories around different ideas how you could implement authorization. We've also contributed an idea, basically how we implement authorization for GraphQL backends, which is basically in a declarative way leveraging the graph structure of your GraphQL backend. So yeah, I definitely agree. This is just the very beginning.
Everyone does it differently.
Yeah,
everybody does it differently.
Yeah. Exactly.
I do everything I decorate my resolvers with authorization.
Yeah, exactly. And I think one common thing we see though is that authorization moves more and more away from endpoint-based authorization, more to a model level authorization.
Yeah.
Right.
And I think this is when you're composing your GraphQL schema, where you reuse a certain type, you don't want to implement the same authorization logic multiple times wherever it's used in your schema, but you want to make sure that this logic can be reused. So is that like a problem you tried to solve for FORTIS, or is it just internally and it doesn't really matter?
Yeah, we're in the midst of trying to solve it right now. So I think you hit the nail on the head. We're kind of like standing up ourselves, but it just seems like something that's at least that abstraction layer for the comments. Obviously, where your roles will subside, where your entitlements will subside is going to be case by case. But that abstraction, that high level GraphQL abstraction, that's the one thing that we're kind of like implementing that right now, but it seems like that's like a common abstraction that people are implementing.
Yeah, definitely. Yeah, I'm very much looking forward to see more ideas about best practices they're evolving. I think this, like the last half year, was very insightful already in terms of best practices, and I'm very convinced that the next year will show a lot of more best practices. Caching is like, I think we should definitely speak about like an entire episode just about GraphQL caching.
We will.
So, yeah. All right. Well, Erik, thank you so much for being on the show today. I'm really excited to have learned about how you guys are using GraphQL at Microsoft, and I'm happy that this way more people can learn about it. I highly encourage you to write more about your learnings there. And maybe we have you in the future again on the show, and you can tell us about your learnings from the next project.
Great. Well, thank you so much for having me, and happy to be on. So
yeah, thank you so much.
All right.
Everybody, remember this show needs a lot of love, so we can keep getting really great people on the show. So please like, share, and subscribe. Hit the like button right now. Start sharing. Share it to anybody else that you want to, your friends, your family, your mother. Do it. And we're available on SoundCloud, iTunes, YouTube, and www.graphqlradio.com. Thank you.